Hello friends, welcome to lecture number 8 of electricity and magnetism. So today our topic of discussion is Kirchhoff's laws and its applications. So before we start, please subscribe the channel and share with your friends, hit the bell icon and also hit the thumbs up button. Right. So now let's start. There are two laws of there are two Kirchhoff's laws. First one, which is also known as junction law. Now you see, suppose at this point current I1 is coming in, and to the same point current I2 is also coming in, and current I3 is also coming in, suppose, and this I4 is going outward, suppose. So I4 is going out, I5 is also going out, right? So let me take current in, suppose positive, and current out is negative. Then according to the junction rule or Kirchhoff's first law, the algebraic sum of these currents at the junction is 0. That means current in, that is I1 plus I2 plus I3, and current out should be taken as negative. Those are I4 and I5, right? So minus I4 minus I5, the total current should be 0 at the junction. Algebraic sum must be 0. So from here we can write I1 plus I2 plus I3 is equal to I4 plus I5, right? So this is current in and it is current going out, right? So this is the first law. Let me write the statement. So this law states that in any electric circuit, the algebraic sum of the currents meeting at any junction in the circuit is 0, right? This is the first law, right? Now let's move on to next law. Now let us discuss about Kirchhoff's second law, which is also known as mesh rule or loop rule. Right, so let us discuss this. Now see this figure. So here we have two loops or two meshes. One is this one. This is the first mesh, this is the second mesh, or first loop or second loop, you can consider that way. So here we have to choose a path to apply this law. I will write the statement later. Okay, let me show you how to apply this law first. Here you see in the first mesh we have two cells. This is with EMF E1, this is the EMF E1, and here we have E2, EMF E2, and current flows from positive to negative, right? In this direction current will flow. This is the direction of I1 current and this is the direction of I2 current. Let me choose the path here in anti-clockwise direction. So here also let me take that anti-clockwise direction, right? So this is the anti-clockwise direction. Now you see, so in loop 1 or mesh 1, in loop 1, if you apply this law, so how to do that? So here you see, as I is in the direction of the path that we have chosen, so that's why I1 into R2. So this I1 current is flowing through R2 also, sorry, R1 also. This is the I1 current, R1. So here you can see so product of the resistance I1 and R1, right? The current is in the direction of the path that we have chosen, so then the product of resistance and current through it is positive, right? We have to consider that way. And here you can see in this mesh there are two currents, one is I1 and I2. This arm is common for both the loop, so that's why I2 is in opposite direction, right? In opposite direction that flows through R2, right? So that's why it will be in negative. So this is the path that we have chosen in mesh 1 or loop 1, and the direction of current is in this direction, in opposite direction. I2 direction of I2 is in opposite direction, right? So that's why it will be negative. I2 R2 is negative, and the sum of the products of this current and resistance in a loop, that must be equal to the EMF, total EMF in the loop. So here EMF is E1 here, and here E2, and here again also you see E1, its direction is same as the path we have choose. So E1 is positive, then E2 is in opposite direction. Its direction is opposite to the path that we have chosen in mesh 1, so that's why E2 will be negative here, right? So now in loop 2, here you see, in this loop you can see through this along this arm, let me take this arm as AB, so current flows I2, right? Let me clean a little bit, just wait. So current in this arm, along this arm, so I2, right? And that flows through R2. So and the path in this loop is this is the direction of the path, which is in the same direction with I2. That's why product of I2 and R2 will be positive for this loop. I2 and R2 is positive in this loop. So then here also again E2 is in the direction of the path that we have chosen here, this cell, EMF of this cell. So that's why E will be positive. Let me write this one on the other side, right? E2 will be positive. Okay, that should be written in written on other side, right? And here in this loop, there is only one cell. There is only one cell of EMF E2, right? Okay, write the EMF on this side. Okay, be careful with that. So now you see along this arm, so here you see this is current I1 is coming along this direction, I2 is coming from this direction. Then along this arm we have got current I1 plus I2, because so this is a junction. So in this junction A, at this junction A, so current entering I1 and I2, right? So that's why current going out must be equal to the algebraic sum of the current coming in. Current going out is equal to current coming in, so current going out must be I1 plus I2, right? I2. Okay, so hope you have understood. Therefore the current through this R3 must be I1 plus I2. That's why product of this current and this resistance, that is also in the direction of the path, so that should be also positive. So plus I1 plus I2 into R3, right? So that's how we can apply the Kirchhoff's second law or mesh or loop rule. Okay, so here that means we can write the statement from these equations. Here you can see, so in a loop the product of the currents and the resistance, the sum of the product of the currents and resistance is equal to the sum of the EMFs in that cell. Okay, these are the total EMF in the circuit and in the loop, and so these are the sum and product of the resistance and the current through the resistances. Okay, those must be equal. So this is according to the Kirchhoff's law, second law, okay, or mesh rule. So let me write here the statement. So this is the statement: in any closed mesh or loop of a circuit, the algebraic sum of the products of the current and the resistance in each part of the mesh is equal to the algebraic sum of the EMFs in that mesh, right? So here in the mesh 1 there are two EMFs, there are two cells E1 and E2 with EMF E1 and E2 respectively, and their algebraic sum is E1 minus E2. Because here E2 is negative, because E2 is in opposite direction to the path that we have chosen here. So here you can see clearly. So let me clean this bit. So this is the path we have chosen, and here you see E2 is in this direction, in opposite direction, because this is the negative sign, this is the positive sign, right? This is a negative and positive. So here in a cell, let me take this is positive, this is negative, and path is from positive to negative. If the path is from positive to negative, right, that means higher potential to lower potential. If the path is from higher to lower potential, then EMF should be considered as negative. If the path we have chosen in the mesh, so here you see for the second loop, this is in loop 1 and this is in loop 2. Here you can see in the second loop, let me clean this. So the path we have chosen in this direction, right, and here the path is in this direction in second loop. So this is E2, right? So from negative to positive. So that's why for the second loop we have written E2 positive when you write on the right hand side. Okay, so hope you have understood this. So if you write this on this side, then it will be negative. Okay, so now let us solve a problem. So let us take this question: calculate the given in the given electrical circuit current in its resistance. The internal resistances of the cells are negligible. That means internal resistance of these cells are negligible, right? So let us solve this. Let me copy this diagram. So let me go to the next slide. Here is the diagram. Then let me name it as this is A, B, C, D. Okay, so how to solve this one? So now here you can see, you can take two loops here. So we are to calculate the current in this circuit, so we don't know the currents here. So let me take this direction as in clockwise direction. Here current is suppose I1 in this loop, and in this loop current is suppose I2. Let me take this one also in clockwise direction, right? So here if we apply the Kirchhoff's law, Kirchhoff's loop rule, so this one is suppose loop 1, this is the loop 1, suppose loop 1, and this is loop 2, right? So loop 1 is here, we can say A, B, C, A. This is the loop 1, A, B, C, A, right? So instead of writing loop 1 and 2, you can write simply A, B, C, A. Loop A, B, C, again A, right? So here you see, so we have taken just let me show you how to use shortcut here. So here you see in this loop A, B, C, just let me show here. In this loop A, B, C, this is A, this is B, and this is the resistance here, and this is C, right? So here we have two resistances. One is 4.5 ohm, another is 1 ohm, right? And here voltage is 2 volt, right? EMF is nothing but voltage. Okay, so this is negative, this is positive, right? So here we have taken the direction of I1 in this direction, right? So here you can see, so first add the resistances. Okay, let me show you how to apply shortcut. 4.5 ohm plus 1 ohm, right, into, then multiply current I1, that current I1. Okay, so current I1, so take this one as, positive, right? Here you see this is the part we have taken, and these are the two resistances here, so add these two and add I1, right? Then this resistance is shared by this loop as well, right? So where in the next loop that we have here, let me represent it by the dotted line ADC. Okay, here the direction of current is in this direction I2, right, which will be opposite to this I1, right? If you see the flow of the current in this circuit here I2, you can see this I1 will be in this direction like this, right, and this I2 will be in this direction, right, opposite. So that's why take this 4.5 I, only this is shared by this loop, so 4.5 into I2, so take this one as negative. Now here you see, let me clean this part. Now look at this. Now see the direction of this I1. So see the direction of this I1 is from negative to positive, right? So negative to positive. So when you write it, write the EMF or voltage on the right hand side. So when you go from negative to positive, that voltage should be positive, right? 2 volt. So hope you have understood this, right? This is 2 volt. Now you see, in some books you may find that they have considered this one as negative, right? 4.5 plus 1 into I2, and they have considered this one as positive, 4.5 I2, and 2 as negative, that EMF in negative, or they might have written on this side as well, this 2 plus 2 on this side. That's how also you can solve. Okay, so different authors use different sign conventions. Okay, don't be confused, just use anyone. So just remember, write the EMF or voltage of the battery on the right hand side. In that case, if the part you have chosen, if the part of the current that you have chosen is from minus to plus, then take positive on the right hand side. If you write, so just you remember, write the EMF on this side and take positive. When we should take positive? When the direction of current you have chosen is from negative terminal to positive terminal. Here we have taken the direction of I1 in this direction, right? This is 2 volt. So when you write on this right hand side, that should be positive. Okay, so that's how we can solve. So hope you have understood this. Now you see, okay, just again add this to, then you will get 5.5 I1. So 5.5 I1 minus 4.5 I2 is equal to 2. This is suppose equation number 1. Now let us take the mesh 2, okay, or loop ADCA. Let me take that loop, or ACDA. Okay, SDA. So here you see, in this loop, this is here's the voltage 1 volt, right? 1 volt, and this is one resistance, and this is another resistance, right? This is A, this is C, D, right? So here it is 4.5 volt, or sorry, ohm, and this is 1 ohm, and this is 1 volt. So direction of the current I2 we have taken in this direction I2, right? So here you see again, add the resistances we have here, that is 1 ohm plus 4.5 ohm into current I2, right? Then this resistance 4.5 is shared by the upper loop also, where we have taken the direction of current I2 in this direction. This is, sorry, I1 in this direction, which is simply opposite to I2, right? If you see this is I2, this is opposite to I2, so that's why minus 4.5 I1, right? Then here you can see, when you write the EMF, you can say this is positive, the longer one is positive terminal, shorter one is negative. Now current in this I2 current is going from positive to negative, right? Positive to negative. I2 is in this direction, from positive to negative. Here you see, in this case 2 volt, the current, the path of the current we have chosen from negative to positive, right? Negative to positive. So when it was negative to positive, we have taken positive on right hand side. Now here we have from negative to positive, sorry, positive to negative, so we have to take this 1 volt negative, right, on this side, minus 1 volt. So hope you have understood this, how to apply this. So just let me cut this. This is equation number 2. Now let us solve this equation number 2. Just wait, let me simplify more. Just this one will be 5.5 I2, then minus 4.5 I1, and right, just wait, 4.5 I1 is equal to minus 1. This is equation number 2. Now if you solve these two equations, right, hope you know how to solve linear equations considering this x and y, assuming that. Just solve it for I1 and I2. So how to solve that? Now you see, let me take these two equations and let me go to the next slide. So solving 1 and 2, we have got these results. This is your I1, this is your I1. Then put the value of I1 in equation number 2. I have done this. This is the value of I2 we have got. So value of I1 and I2, these are the two currents. So that means, you see, we are getting both positive values. So here you see, let me draw the diagram here again. This was the diagram, right? So we had shows the current in this loop in this direction, I1. So I1, right? So we are getting I1 is positive. That means the current is following in the same direction that I have taken in this loop. That means I1, that is 0.65 ampere, is flowing in this direction, right? Flows through the 1 ohm ampere is 0.6 ampere. Then I2 is also positive, we have got. So current through this circuit is also positive. So that is the direction is in this circuit also as same as, so as we have taken in the diagram, right, to apply the Kirchhoff's rule. So here you can see what we have got: current through just use the names here, A, B, C, D, right? Current through BC is 0.65 ampere, right? And current through CD in this direction, CD, that means through this resistance is 0.35. but current through the 4.5 ohm resistance, that means along AC. So along AC is what will be the current. Now you see direction of here you see in this case I1 is greater than I2, right? I1 is greater than I2. Therefore the resultant current will be in this direction, along the I1 direction, right? So here in this direction, what will be the current, value of current? Now I1 is in this direction according to the direction that I have chosen. We have got positive value, so therefore the current flows through in this circuit is in this direction that we have choose the path, right? But I2 here, this you see I2 flows through this, flows in this direction, and as we have got I2 also positive, the direction of I2 is same as the direction of I2 we have considered. We, before solving the problem, we have assumed this direction, right? If you had got negative value, suppose you have got I2 is equal to minus something, minus 5 or something else, then that should be opposite to the direction that you have considered before you have got the value, right? But as we are getting the positive value, so that will be the same as the direction that we have considered. So this is the direction of I2, which is opposite to I1. So therefore current through this AC, that means along the across the 4.5 ohm resistance, we will get this is I1, sorry, this is I1, so I1 minus I2, right? That's gonna be equal to I1 minus I2, that's gonna be equal to 0.65 ampere minus 0.65 ampere minus 0.35 ampere. That's gonna be equal to 0.3 ampere, right? So this is the current through the 4.5 ohm resistance, and this is the current through BC, means 1 ohm resistance in the arm BC, right? So hope you have understood. We have got all the three currents in this circuit. So thank you for watching this video. Please subscribe the channel and inspire me to create new videos for you, and also hit the thumbs up button, share with your friends, and also hit the bell icon so that you get notified when new video will be uploaded. So see you in the next video. Thank you.